Hi friends, welcome back in the another video of feature importance, or we can say the feature engineering, right? So here today we will see the careful cross validation and bootstrapping. Again, like before starting, I would like to recall that what the engineering and the cross validation exactly is. Now, basically what happens sometimes a model might fail to work as per expectation, right, in the training data itself. And a model may even appear to be performing very well in training, but might fail to replicate the performance on unseen data, such as we can say the test data. But what could be the reason for such behavior? Have you ever think about that? So basically what happens, sometimes the model might be good, but the data might not be perfect or might require some more pre-processing, right? Or maybe the model performance isn't being tested the right way. So in that case, we apply the techniques of feature engineering. Okay. So if we sum up the feature engineering, so it is the process of using domain knowledge of the data to create features that make machine learning algorithm to work, right? Now what the cross validation is, so basically cross validation is a very useful technique for assessing the performance of machine learning models, right? It helps to assess the machine learning performance or the model. Okay, and it helps in knowing how the machine learning model would generalize to an independent data set. Like you want to use this technique to estimate how accurate the prediction your model will be in practice, right? So here we use the term as k-fold. So basically k-fold is nothing but here we shuffle the data set randomly actually. So we can split the data set into k folds, right? Now sometime we need to know that how the k-fold cross validation works. So basically if k-fold or the cross validation is used to optimize the model parameter, then the training set is splitted into k parts, right? That means training happens k time, each time leaving out of different part of technique set. Okay, and typically the error of these k model is averaged, we can say. So this is done for each of the model parameter to be tested, and the model with the lowest cross validation and validation error is chosen. Now before wasting our time, let's get start with the case study. So basically we have this context that dataset contains 1000 entry with a 20 categorical symbol attribute prepared by Professor Hoffman, right? In the dataset, each entry represents a person who takes credit by a bank. Each person is classified as good or bad credit risk according to the set of attribute. The link of the dataset can be found below, right? So this is the link for the Kaggle where we can get the same dataset. Now these are the attribute information regarding the data set, and what we want to do is we want to gauge the feature importance with the data set. So let's start with the step by step. First we import the necessary library, that is numpy, panda, matplotlib, right? Seaborn, matplot inline, warnings to ignore all the warnings, right? Now we are importing the interactive cells, right? So here we use that by ipython.core interactive cell. We import it and we are doing it for all, right? All node of interactivity. Now we read the input file and understand the data. So basically we have the CSV, that is credit data CSV. Will be providing the link for the CSV in the description as well. You can find it from there. If we check the shape of data, we normally do df.pre.shape, so it will return 1000 rows and 21 columns. Now if we get the information, so these are the information of all these columns. So you can see the column name, their null values or not, and their data types. Now if we get the head or top 5 rows, so here you can see that this are data set contain all these values like this, right? Now these are the columns. Again we are fetching the columns from dataset.columns. Now what we are doing is we randomly select 50% data for this use case. So how will we do that? We simply do that in the help of train test split. We are taking the data, right? We are passing the train size as 50%. That means that rest 50 will be for test size. Random state, we are passing an integer, that is 5. Now df dot shape, it will print, df dot column, it will print, and df dot hat. First it is df dot shape again. Now the df dot column, all that we have, and top 5 rows of the data set. Now let's build an ensemble model, but need to modify the data set first. How? Because we have seen that this also include the object, right? So df dot select data type, which include object, we are getting that, and we get all these data set here. Now in dff we are getting the dummies, right? How? From df we are getting dummies for all these columns. So if we do dff dot shape, so these are the shape of data set. Now let's check for highly correlated variables. So core dot dff dot correlation, right? So all these are value. Core dot log, right? We are getting the values. np dot trial, right? Core k equals to -1. Similarly core dot stack, we pass it and we get the correlation, right? Correlated variable we get like this. So you can also analyze according to your requirement. Now we drop the irrelevant data. So what are the irrelevant data in our case? So all these columns seems to be irrelevant in our case. Access 1 means we are dropping all the columns. Now split train test data with the 70:30. So that means 70% is for train size and 30% is for test size. So for y we are taking default, and for x we are taking all except default, right? So x train accessed, y train y test, we do train test split on the basis of xy. Test size we are passing, random state is again 42. If we print all the shapes, so we get it like this. Now we build RF model. So how we do that? We RF is nothing but random forest classifier here. So we are importing the random forest classifier from sklearn.ensemble, right? We pass number of job, right? Number of estimator, then criterion is entropy, random state is 4 times from 9. Now rf dot fit, we fit this x train and y train into random forest classifier. Now we get the predict into predicts variable, and for y predicts, right, we do the rf dot predict of on x test. Now we calculate the confusion matrix. So here we import the confusion matrix from matrix, the accuracy score from matrix as well, right? We calculate confusion matrix as y true, y prediction, and cm equals to confusion matrix y true or y prediction, then we print the cm. Now we calculate the confusion matrix of y test, y prediction. So we first print the accuracy score. So this way you can see the accuracy score, we got 71%, right? And this is nothing but the calculating of confusion matrix. Now view a list of the feature and their importance score. So importance equals to rf dot feature importance, right? So indices we are passing np dot, we are doing arg short, right? Importances. And then in a we are getting all these columns. Then in features we are getting a default, sorry, in features we are getting except default. Now we try to plot it, right? So here you can see that we did this. So these are our feature importance. So the higher we can see is age, right? So age is very high with the relative importance, right? And the lowest is nothing but the credit history critical amount, other credit existing. Now we store train result from rf dot score x train y train, then we do test result rf dot score x test y test. The train accuracy we get as 100% of, and if we get the test accuracy we get it as 71%. Now if we do the k-fold cross validation, right, first we will try without stratification. So usually k is set as 10 to 20 in practical settings. Now that also depends on the data size. So what we are also taking is 10 here. So we are importing model selection, importing k-fold, and model selection importing cross validation score. Number of fold we have 10, seed we are passing 77. So k-fold equals to k-fold, n splits number of folds. Now random state equals to seed. So result equals to cross validation score. RFM we are passing x, y, cv equals to k fold. So result we are getting this array. Now from sklearn dot model selection import k fold. From sklearn dot model selection import cross validation score. Number of fold equals to 10, seed equals to 77. So k fold equals to k fold and split equals to number of fold, random state equals to seed. Now results equals to cross validation score. So we are getting it from RFM x, y, cv equals to k fold. Results equals to, this is what we are getting as result. Now np dot mean we are getting absolute of result. So this is nothing but 77%. Result dot standard, so we are getting it 0.5%. Now leave one out cross validation. So we import leave one out, right, from model selection as well. Then cross validation score. So here in score we are getting the cross validation score by passing this cv as leave one out. Rest is same as we just passed. Now here we got this array. So because we have 350 sample, we leave one out cross validation, yield score for 350 trials, and the score indicates either defaulter 1.0 or non-defaulter 0 prediction, or we can say 1 or 0. Taking the mean of these gives an estimation of the error rate. Now if we do scores dot mean, so we get it as 78. Scores dot standard deviation, we got it as 41%. Now if we do stratified cross validation, that is bonus, right? So k fold cross validation with stratification, we can say that. So this time we will import stratified fold, right, and the cross validation we are passing here all the parameter in stratified fold function, that is n split is equal to k, which is nothing but 10 in our case, and random state is 50. For result we call the function and we pass the stratified fold as cv. Now if we check the accuracy score, average and standard deviation, so accuracy score, the average is 77%, standard deviation we are getting as 0.1%, right? Now bootstrapping bonus. Okay, so what again the bootstrapping we will apply here. So given a data set of size n, a bootstrap sample is created by sampling n instances uniformly from the data with or without replacement. Now create a model with each bootstrap sample and validate it with the test set. Final result is calculated by averaging the model or averaging the accuracy of models. Now number of iteration for bootstrapping is, bootstrap iteration is 10, accuracy we are getting it. Now from sklearn.utils we import resembles, and sklearn.matrix we import accuracy score. So for I in range bootstrap iteration we are calling x and y, resemble so we call xtrain ytrain, rfm.fit we call the x and y prediction equal to rfm dot predict, so we call it as x test. Now accuracy score we are storing it in accuracy dot append acc. So here you can see that this will be going into this iteration, right? So here we have the result of all the iteration. Now if we check the accuracy again, right, so if we got the accuracy mean, so we got it as 68%, and the accuracy standard deviation we got it as 0.016%. Now here according to this analysis by our team, so what we got is here the cross fold validation with stratification gives better result with that than bootstrapping. You can simply compare this accuracy score and the bootstrapping accuracy score, this one. So let's take the average only. So here we got 77%, but here we got this 68%. Meanwhile the standard deviation here we got is 0.01%, right, and here we get it as 0.196. So this is what you can clearly see the result or the difference in the result of k-fold cross validation and bootstrapping. So friend, this was all about this video. We'll come up with next video as soon as possible. Stay tuned. All the best. Have a good time.